Hello everyone, this is the final part of tutorial dedicated to tree cutting, and today we're gonna finally add a possibility to cut a drop trunk and collect wood. Also, we would like to mention that we're not gonna add a collection logic, adding to inventory, because everyone has its own inventory system and you will have to change a logic that we're adding here to fit your inventory system. So, first thing that I want to do, I would like to make some changes. Let's open a tree blueprint and I want to move a tree cutting box. I think that I want to remove it. I think that I don't need a tree cutting box, by the way, and our tree has its own collision. So we can open a static mesh, show simple collision, and we can see it here. So I think that this collision will be fine. Well, back to a tree. Um, I want to move chop particles and make them a child of a trunk, like this. Why do I want to do that? Because I want to show these chop particles when I will chop a trunk of a tree, when it will lie on the ground. Well, now we have to make some changes for chop particles. Let's open event graph and on event chop we're setting a world rotation of chop particles, and now x and y are not always gonna be 0. So we have to get chop particles and get world rotation of them. Then split this onto pins and connect x and y here. Well, that looks fine. Now what we're gonna do here. When our health is below 0, we should also be able to decrease it. So I'm gonna remove a clamping right here, and it should be clamped between, for example, -100 and maximum health. Well, it's on your choice what is a health of a trunk. So let me create a new variable and call it trunk health of type float, and it should be something like 45. So we will have to make 3 hits to destroy trunk. And here we're checking if health is less than or equal to 0. Well, right after that we have to right after that we're calling on tree cutted. But we have to call on tree cutted only once. And let's create a boolean flag called is tree cutted of type boolean. And by default it is false. And right after calling on tree cutted we're setting is tree cutted to true. Well, so here we can now add a branch and check whether tree cutted or not. If it is not tree cutted, then we're calling this function. And if it is cutted, then we're just checking our health. So we're getting getting a health, and we should check whether it is, if our trunk health is 45, then if health is less than or equal than -45, then a trunk should be destroyed. So let's check, let's multiply it, or not, let's check if it is less, not just less than or equal to minus trunk health. To trunk health, multiply it on -1 and plug it here. Well, and add a branch. So if it is, then we have to create a new event. Let's create a new event and call it on trunk cutted. And let's call this event on true here, on trunk cutted. Compile and save. Well, what we want to do on trunk cut it. On trunk cut it, we have to destroy a trunk at first. So we're getting a trunk and destroying. Or not even destroy, we just want to set its visibility to false and disable its collision. So its new visibility is false and set collision enabled, no collision. Well, also it depends on you. You may call this event, for example, for some delay after tree cut it, for example, 5 seconds passed, and you're calling this event. If you don't have an animation for cutting from up to down, for example. Well, right after that we have to spawn logs. But for me, I have a problem with my animation because my second animation for cutting from up to down it doesn't have a needed event. So it will not be handled. Hits on trunk will not be handled. We have enable hit collision and disable hit collision events on horizontal animation, and I have to add the same events for attacking from up to down. So what I'm gonna do, I'm gonna enable add notify here, and it's gonna be called enable hit collision here, and disable hit collision here. Now it's gonna work. Let's test it out. Okay, collision doesn't work for that because let's open a tree, select a tree here and check if it overlaps world static. And it doesn't. Let's make it custom and select overlap world static. Also, I didn't check. No, we don't need to do that. It should block world static. I'm sorry, and we have to change an object type from world dynamic to world static because Stone Axe is overlapping only world static. Compile, save, and play. Okay, let's wait till I will cut a tree. Well, now it has fallen, and now I can. Also, I forgot to change object type for trunk from world dynamic to world static. Compile, save, and I'm gonna set a health from 100 to 15 by default, so we'll not need to wait until I cut a tree to the end. Okay, looks like we don't receive a hit. Well, so something is not working. Okay, we're doing this only if health is greater than 0, and we should delete this branch now. Now let's compile, save, and test it again. Okay, at least now it... Oh, chop particles are a little bit broken, but as you can see, tree is destroyed, so we have destroyed it. But what's wrong with chop particles, by the way? Okay, I'm setting X and Y rotation and yaw rotation. Well, in this case, we don't have to set a yaw rotation, by the way. Yes, your rotation doesn't mean anything here. Okay, let's delete chop particles for now, and I'm gonna attach them back. Well, now we have destroyed a trunk of a tree. Well, what's gonna be the next part? The next part we have to spawn something. So let's create a new blueprint, actor, and let's call it, for example, BP wood. Or wooden log, whenever you want to spawn. Okay, open it up, and it should have a static mesh component. And let's let it be just static mesh and select some log. For example, I have some log from Megascans. Here it is. Okay, how much? Okay, it's nanite mesh. I don't want to spawn nanite meshes. Maybe this one. Well, this one is fine. Okay, this is gonna be my log. Now let me move it somewhere in the scene. I think that it is too big, so I'm gonna scale it to 0.5. Even more, 0.3. So this is gonna be, for example, a resource that is spawned here. Well, and it should have a sphere collision. Sphere collision. Also, I want to let's make a static mesh a root of this BP wood, because this static mesh is gonna simulate physics. Like this. And attach, oops. Okay, this is fine. Let's increase a size of a sphere. Let's make it 100, for example, and change its collision type to custom. Object type doesn't mean anything for us now. It should ignore everything except pawn. It should overlap with pawn. Well, let's open BP3 now. And now we have to spawn this BP wood. Well, we have to spawn it somewhere. We have to know locations where do we want it to be spawned. So, can we get random location in the box? For example, get random location. No, only in radius. Well, I'm just thinking what's gonna be a better way to spawn them, from one place or from a few places. Mm. Well, I think from one place will be fine, so let's add a sphere here, so also sphere collision, and call it spawn wood spawn place, and move it onto our trunk and make it somewhere and locate it somewhere in the middle. Also, let's disable all collisions. We can use an arrow here also, but I prefer using sphere collisions without no collision because it's easier for me to find them. So now let's open an event graph. Well, on trunk cut it, what do we have to do? We have to define how much wood can be spawned. So let's define it. For example, I don't know, wood spawn count min. Let's make it an integer value, duplicate it, and max. And for example, let's make a min to be 3 or 4 and max to be 5. Well, what we have to do now? We have to generate random integer in some range. For example, from min wood spawn count to max wood spawn count, so that we will spawn a different amount of wood every time. And we have to make for each loop. For each, not for each, just for loop. We have to make for loop, and first index is gonna be 1 at this case, and an end index is gonna be this random integer. Well, now we have to spawn this wood. We have to get a location of a wood spawn place. Get world location. Let's split it and let's add a little bit to that value so that we will ensure that our logs will spawn higher than they can. Let's make it, for example, 50. Oh, 50 maybe is too much. Okay, no, I think 50 is fine. 50, and we have to spawn actor from class. And the class is gonna be BP wood. BP wood. Well, let's split spawn transform location and split spawn transform, and let's now split transform location. Well, that value goes into that. Now about x and y. I think that we have to add some deviation to x and y values. So I'm gonna add some random float in range to x, and it's gonna be from 150 from 0 no from minus 100 to 100, and I'm gonna do exactly the same for y value. Just connect y here. Well, this goes to y, this goes to x. Compile and save. Scale should be 0 or 1, and spawn transform rotation. Well, we can make that to be a random float. Let's random float in range from 0 to 360. Okay, now wood will be spawned. Let's select collision handling override to try to adjust location but always spawn. And now let's open BP wood. Well, on begin play, what we physics to true. Well, now let's test it out and see what will happen. Okay, this wood is just simulating physics. Here it is. Here are our logs had spawned, but their angular velocity is too big. So let's select BP wood, select static mesh, go here on the physics section, and let's increase angular damping to 5, for example, and linear damping to 0.5. Or not 5, maybe 0.5, 1.5, I think will be maybe fine. Okay, and as you can see, well, I'm not sure if a mass will help us here, so let's add a mass to wooden logs and let's make it 1500 and disable any impulses that we can do. I'm not sure that it will help, to be honest. Well, now our wooden logs appeared and they're simulating physics. Also, I'm not gonna simulate physics for them, to be honest. I'm just showing you how to do that. So right after that, we're gonna make it in a little bit different way. EMS helped us, so here is how our logs look like. Or maybe I will leave it, I don't know. Where is this log? Well, okay, what should we do now? Now our logs should be added to an inventory somehow. So that's a reason why we have added this sphere collision. Also, maybe I think that its size is correct. Let's select it and on component and create an event for on component begin overlap. Here it is. Now what we're gonna do? We're gonna check if other actor is our character. So what we're gonna do, we're gonna just cast to BP main character. Well, in my case, my character has something like inventory component, and I can call add items to inventory, and I can pass some ID, quantity. In your case, you can do it by as you wish. But the main thing that I want to create now is I want them to navigate to a player like in Valheim or for example in Lego Fortnite or in a lot of different games. So what we're gonna do here, we're gonna get the static mesh and set simulates physics to false. And now I want the sphere to fly right to a player. So what do we have to do? We have to create a timeline. Let's create timeline, and call it something like player move to player timeline and play it from the start. Okay, what it should have? It should have a duration, for example, 1.5. Well, I'm sorry, I was interrupted a little. So we have stopped on timeline. So here we have to select a duration and let it be 1, for example, 1 second. And let's create a track. And we're gonna add a flow track and call it alpha. So let's add 2 keys. First one is gonna be 0, 0, and second one is gonna be 1, 1. Save, compile, back to event graph. Now we have to change the location of our actor. So we need to set actor location every update. Also, I want to set actor scale 3D. And before we have started doing everything here, just in case, we have to disable collision for our sphere. So set collision enabled to no collision. I don't know how it will look like, but let's test it. So, and actor scale is gonna be 0. And we have added timelines to make it smooth. So let's lerp it, lerp a vector from A to B. A1 alpha is 0. So A is gonna be a current scale and default scale, and default scale is gonna be 1, 1, 1. So we're gonna lerp with this alpha. Now about actor location. We're gonna use a character location. So let's drag our character from cast to whenever your character class is, and get actor location and plug it. Oh no, not plug it here. I'm sorry. And we're also gonna lerp. And this is gonna be a B value, and A is gonna be a current location of an actor. Also, don't forget to connect alpha. So we're gonna get actor location and plug it into A. Well, also, before doing everything here, we have to disable a collision also on a static mesh. Set collision enabled. To no collision. Well, also be sure that your static mesh have a collision by itself. In other case, it will fall through a landscape during simulating a physics. Well, and on finished, we're gonna add item to an inventory and destroy an actor. So let's call destroy actor at first, and let's test it out. Let's test how it will look like. I have a wooden lock here, for example. If I will move closer, well, scale of 111 is a little bit too big, as we can see. So what we're gonna do, we're gonna get actor scale 3D and plug it into an A value. Okay, I even didn't mention how it worked, so let's chop a tree. 1, 2. So, as you can see, trees are collected, and the last thing that we have to do, the main thing that we have to do, is to add some items to an inventory, but that's on your... You select how to do it, so I'm not gonna add it into a video because it differs from everyone, but it should be done here, right after destroying, not right after, right before destroying an actor. So, I think that's all for this video, for a main part for this video. So if you're fine with it, then you can just stop watching. Thanks for watching this tutorial series. But I want to make some changes to make a cutting of a trunk when it is falling more beautiful, because now it looks a little bit strange and I don't like it. So if you want to see it, then stay with me here. Now, I'm navigating to BP3, and what I want to do, we are changing material for a trunk here, for a tree when we're cutting it. Well, we cannot do it for a trunk without big changes in material, because if we will hit a trunk somewhere here, then it will be changed here with material. What I want to do, I want it to move a little bit, like it will have an impact from a hit. So, here is what happens when we hit a trunk. So everything that we should do when a trunk is hit should be done on this false statement. Well, we have already added an impulse to a trunk, so I'm gonna do it again. I'm gonna add an impulse without velocity change, and I'm gonna set x to 0 and z to, let's test 150. Let's test 150. Okay, let's see, will it have any effect, by the way? I'm not sure. Maybe it's too small value for a mass. For a mass of a trunk. Also, I will increase the trunk health from 45 to 150 for debug reasons. Well, nothing happens. Maybe an impulse is too small. Let's make it 1000 500 here. And also my animation should enable hit collision before this happens. It should enable this collision right here, I think. Okay. Well, I want to finally fix an issue somehow with these chop particles. I don't like that we cannot see them. So we gonna find look at rotation for them. Well, they have to look always somewhere up. So they have to be rotated X and Y should. Well, what we're gonna do? We're gonna copy this chop particles get world location, find look at rotation, just copy them. Well, we also have to somehow change their location, by the way. Let me think a little, but now let's test an impulse. We're adding an impulse of 50 on X with velocity. But this hit location is a little bit incorrect. It's a location of a player. It's a location of a player, but we have to move it along our trunk on that axis. So let's try to do it this way. I'm not sure that it will work. So let's get chop particles and set. First we have to get our character location in a relative space of a tree. So we're getting a hit location. Let's move it somewhere here, add a reroute node. And what we're gonna do, we're gonna transform location. Well, we have to provide okay, it has a world transform. It's a world location. Oh, by the way, we don't even need it. Let's open our BPI choppable and first let's rename this hit location to an actor location. Compile and save, and let's add a new parameter and let's call it hit location. Well, and the hit location is gonna be that one that we've tried to add earlier. Well, let's open our instrument here and on begin overlap, disconnect player character actor location from hit location. It should be connected to an actor location like this. And the hit location is gonna be box get world location. Like this. Compile, save, and back to BP3. And connect actor location here instead of hit location. Well, now we have to find the difference between chop particles and a hit location. Well, we have to get hit location and move it here, reroute node. And this hit location is also in world space. So we have to transform its location. How does it work? Transform a position by supply transform. Well, if I will use just get actor transform here, no, it will not work. I think from local to... Okay, I'm not sure how to do it from local to local, and let me think a little bit. Well, I finally found that I have used incorrect function. So we have inverse transform location to convert from world to local, and the transform should be get actor transform here. So this is gonna be a hit location in a relative space of our actor, but our chop particles are located not in just in the actor. It has a relative transform on our trunk. So it should not be an actor transform, it should be get trunk and get its world transform. Get world transform here and plug it here. Well, now we will know a hit location on a trunk space. Well, and what it's gonna be, we're gonna change that value of a chop particles, because if trunk is gonna be rotated, chop particles should be moved on Z along a trunk. So what do we have to do? We have to select chop particles and set a relative location. And let's change an impulse. I don't remember if we tested it. So, and X and Y should be the same as current. So copy paste and get a relative location, split it. Well, now XY goes into XY, XY, and Z from inverse transform location goes into location Z. Well, now chop particles should be located in correct position, but let's check it. Well, if I'm gonna hit here, it's located here. If I'm gonna hit here, it's located here, and okay, now chop particles are located in correct way, but they are not facing our actor. So they even don't have to face our actor. They should face up vector. Well, let's open a BP3 here, and right after we have set it up a relative location of the chop particles, we have to rotate them somehow. So we have to find their look at rotation. So let's call a function called find look. Well, I'm gonna just copy it from there. So find look at rotation, and start is gonna be world location of our chop particles, and end is gonna be the same, but let's make vector and break world location. X, Y should be the same, but Z should be Z plus, for example, doesn't matter. Let's make 1000. And then we should get chop particles and set world rotation. And here we can just plug this rotation fully, I think. And let's test it. Also, I think that I didn't see any. Just for debug reasons, I'm gonna call... No, I can't call it chop, I think. Oh, no, I'm gonna call event chop on begin play. Event chop. Chop. Just chop. Yes, just chop. I'm gonna call just chop here. No. This one. Damage is gonna be 100, doesn't... No, not 100, of course. How much health by default? 15, so it's gonna be 15. Okay, so it should fall now. And we don't see any impulse. Well, what is wrong with it? Maybe we have set it up here something incorrectly? No. No. If I will set 1000. Okay, 1000 is fine, so it should be positive value, but a little bit smaller